Welcome back everyone. In a previous video, we have learned about the radioactivity in which we learn about alpha, beta and gamma decay. If you remember, we have learned that what is radioactivity, then substances whose mass number is greater than 170, they have less binding energy. Because of that, they wants to increase the binding energy, and to do the same they have to decrease corresponding nuclei or atomic mass number, and for that purpose they disintegrate themselves. This process of disintegrating themselves is called as what? Radioactivity. So we have one law called radioactive decay law. So let's learn radioactive decay law. Remember, you are watching mahasarkar.co.in. Okay? So, what is radioactive decay law? Just imagine very few things. मी सुरुवातीला मुद्दा म्हणून गरजेचे जे आहे ते इमॅजिन करा. माझ्याकडे एक सबस्टन्स आहे, सबस्टन्स एक्स. या सबस्टन्स एक्सचे 100 न्यूक्लिआय आहेत आत्ता. सेम सबस्टन्स एक्स मोर क्वांटिटीमध्ये 200 न्यूक्लिआय आहेत. सेम सबस्टन्स एक्स 100 न्यूक्लिआय अँड 200 न्यूक्लिआय असे माझ्याकडे आहेत. ओके, मी म्हटलं की सबस्टन्स एक्स आय हॅव ऑब्झर्व फॉर 5 सेकंड. दिस ऑल्सो ऑब्झर्व फॉर व्हॉट? 5 सेकंड. I found that after 5 seconds here number of nuclei which will remain was say 25. Here number of nuclei was remain was say what? 25. What do you expect? How much number of nuclei will remain here? Can you relate from the first question? इथं काय बघा, सुरुवातीला 100 न्यूक्लिआय आहेत, 5 सेकंदानंतर तिथं राहत आहे 25. इथं 200 आहेत, तर मटेरियल तेच आहे, तर 5 सेकंदानंतर इथं किती राहायला पाहिजे? तर एक लॉजिक असं लक्षात घ्या की प्रत्येक 100 मागे 5 सेकंदात 75 न्यूक्लिआयचं डिसइंटिग्रेशन झालं. तर इथं प्रत्येक 100 मागे 75 म्हणजे टोटल 150 न्यूक्लिआय विल डिसइंटिग्रेट, सो दॅट number of nuclei will remain here is what? 50. So what this law indicates, what this mathematical conclusion indicates, this is nothing but the radioactive decay law. This is nothing but what? Radioactive decay law. To understand this again in a detail, consider let n be the number of nuclei present at any instant. When you saw any material, जेव्हा तुम्ही एखादा मटेरियल बघितलं, number of nuclei present was what? n. Okay. Now say time is changed by small fraction. So let dt be the small time interval. Small time interval. So that this number of nuclei are changed by fraction, say dn. So dn be the number of nuclei disintegrated. Number of nuclei what? Disintegrated in time dt. Then how will you write rate of disintegration? See how many nuclei disintegrated? dn. In how much time? dt. Then rate of disintegration. Rate of disintegration, that is number of nuclei decayed per unit time, that is equals to what? dn upon dt. Rate of disintegration is what? dn upon dt. This will be the rate of disintegration. Now as I said initially in the mathematical conclusion, this rate of disintegration depends upon what? Number of nuclei which are present at any instant, and therefore statement of the law can be stated as rate of disintegration of radioactive element is directly proportional to number of nuclei present at that instant. त्यावेळेला जेवढे न्यूक्लिआय प्रेझेंट आहेत त्याच्या प्रपोर्शन मध्ये डिसइंटिग्रेशन होणार and therefore I can write dn upon dt directly proportional to n. एकदम सोपं आहे. dn upon dt directly proportional to n, where dn upon dt is what? Number of nuclei disintegrated with respect to time, and n is what? Number of nuclei present at that instant. So dn upon dt equal to minus lambda into n, where lambda is constant and called as decay constant. It is called as what? Decay constant. Now why this minus sign here? Then remember, आधीचे न्यूक्लिआय जास्त आहेत आणि नंतर जे असणार आहेत that will going to decrease. Total number of nuclei are going to decrease, and therefore I will say negative sign indicates that the decrease in the number of nuclei of the substance. We just have to adjust some things here. So say this is equation 1. This equation 1 is in the terms of rate of disintegration. That is, we call this type of integration of differential equation. We have to solve this equation. To solve this now, rearranging the terms in a equation 1, we get what we are going to get here. See, what I am doing is I am shifting this dt towards the RHS and n towards the LHS. So what we will get? dn upon n is equals to minus n lambda into dt. This is differential equation. So on integrating both sides, काय मिळणार आहे बघा, integrate both sides. So integral of dn upon n equal to minus lambda is constant, integral of 1 into dt we can write like dt is into 1. Now see, n is the term in the denominator and its differential term is in the numerator. So it is like f dash upon f of x. Integration of f dash upon f of x, if you remember, it is log of f of x equal to minus lambda. Integration of 1 with respect to dt will be t and say plus c. So this is equation number 2, where c is constant of integration. C is what? Constant of integration. Okay. Where c is constant of integration. To find the value for this c, we just have one condition. When time t is equals to 0, that means that material is just obtained, just born, then say n equal to n0. n0 is actual number of nuclei present at that instant. So if I put these factors here, then what we will get? Log of n. n is equals to n0. Remember, this log is always having base e. So instead of log to the base e, one can write ln also. Okay. E is equals to minus lambda into 0. That means 0 plus c. That means c is equals to log n0. This is equation number 3. So now put value of equation 3 into, then we will get log of n is equals to minus lambda into t plus log n0. Plus log n0 will shift towards the left side. Log n minus log n0 is equals to minus lambda t. Log n minus log n0. So it is the subtraction of two logarithms. That means actually it is log of n upon n0 is equals to minus lambda t. Okay, if I said it is having base E, everywhere base should be E. Initially only I told you, everywhere will be the base E. So if I use the definition, then E raised to this equal to, if I want to eliminate the log, then by definition of logarithm, I can say, by definition of logarithm, we can write n upon n0 is equals to e raised to minus lambda t, or n equal to n0 into e raised to minus lambda t. This equation gives the decay, that number of nuclei decayed is depends upon the actual number of nuclei present. Okay, so this is the term considered as what? Decay law. Equation 4 gives us the decay law. Okay guys, now we have some basic things that we need to just keep in mind. Now see, here the quantity number of rate of disintegration, negative rate, is also called as activity or activity rate, indicated by A of T. Okay, now if I use this equation in the basic formula, then dN upon dt, using this, therefore I can say, if I just adjust this term, like dN upon dt is equals to minus lambda into n, minus sign shifted here, so this is minus now, but as I said, this is nothing but what? An activity, so I will say A into T is equals to lambda into n. But what is n again? Then n is nothing but this equation, so therefore A into T is equals to lambda into n0 e raised to minus lambda t. When t is equals to 0, then e raised to 0 is equals to 1. Therefore A into t is equals to lambda into n0. या टर्मला तुम्ही a0 ने इंडिकेट करा, so I can call this term as a0. Okay, so again this equation 5 can be written as at is equals to lambda into a0. Okay, at can be equal to a0 into e raised to minus lambda t. This is the activity rate. Remember, SI unit of activity is Becquerel. SI unit of activity, SI unit is Becquerel. Symbol is BQ. BQ stands for 1 BQ stands for 1 decay per second. Okay, there is one another unit called Curie. 1 Curie is equals to 3.7 into 10 raised to 10 decay per second. So this is nothing but the radioactive decay law. Okay, now when we discuss the radioactive decay law, one more important term is should be definitely discussed, that is called half-life time. So what is half-life time? एकदम सोप्या शब्दात, the time in which the total number of substance will be disintegrated to its half of the value. Are you getting that? The time in which half of the life of that material is done, then that we call as what? Half-life time. So half-life time indicated by capital T. Now we are going to have three equations. आपण बघितलं ते बघा. पहिलं इक्वेशन n equal to n0 into e raised to minus lambda t. आता when for t equal to t means time is equals to half lifetime, that is half lifetime, then material will be remain is equals to half of its actual number of nuclei. Number of nuclei remain for this time if half of the actual number of nuclei. So n equal to n0 upon 2. याला simplify करूया. Therefore we get n0 upon 2 is equals to n0 into e raised to minus lambda into capital T. N0 get cancelled. Half equal to this minus should be shifted to the denominator. So e raised to lambda t. That means e raised to lambda t equal to 2 तुम्हाला मिळणार आहे. Taking log on both sides, what we will get? Log e raised to lambda t is equals to log 2. So it will be lambda t times log e equal to log 2. Okay, log e ची value to the base e is 1. So lambda t equal to log 2. So t can be equal to log 2 upon lambda, where lambda is decay constant. If I find value of log 2 to the base e, children remember we always used to write log of 2 to the base e, म्हणजे इथं base e असणार आहे 693 upon lambda. This is the equation for half lifetime. If you plot the graph of dn upon dt to n, that is number of nuclei at that instant, then that graph is exponentially downward. Because of this, the base e is there. Every time when you find these values, that values will indicate that they are not increasing or decreasing linearly. Actually it is decreasing, but linear decrease is not there like this. It is decreasing in the exponential form. Hence we are going to use the exponential term in the logarithm. I hope you understood this. And here we have done with one important lesson. Thanks for watching mahasarkar.co.in. Thank you.